Hi, good evening everyone. Welcome to YouTube classes, Unacademy YouTube classes. Are you getting now? Are you getting or not? Hello guys. Are you getting? Yeah. Hello, good evening everyone. Hello guys. Are you getting now? Are you getting? So welcome to Unacademy YouTube channel. Hello, good evening everyone. Hello guys. Are you getting now? Are you getting? So welcome to Unacademy YouTube channel. Are you getting? Hello guys, good evening. So welcome to Unacademy YouTube channel. So today we'll continue that current electricity next part. Right. See guys, so in current electricity we have completed what resistance series and parallel methods. Na? Next, I will give you Kirchhoff laws. Kirchhoff laws. Kirchhoff laws and Weissenbridge principle. So based on that, we'll do problems. Okay, right. So anyone is there on live? Just give your replies. Everyone who are watching live here. Anyone is there? Who are watching? Right. See, Kirchhoff laws. Kirchhoff laws. See, these Kirchhoff laws are based on what resistances and cells. Means in circuits we can use these Kirchhoff laws to find EMFs and what different currents, potentials, and different things to find that we can use these Kirchhoff laws. Okay. So we have two laws, Kirchhoff two laws. First one is law of junction or junction law. First one is what? Junction law. Second one is loop law or law of voltage, law of current. Law of currents. See, in any circuit, see, see, this is a junction to meet all resistances. Suppose here see I1 current is flowing, here I2 current is flowing, and here see I3, I4 and I5. These are flowing, see these are coming towards the junction and they are what moving away from the junction. So the Kirchhoff first law is what? The sum of the currents. See, the sum of the currents entering to the junction. What is that? I1 plus I2 equal to sum of the currents leaving the junction. I3 plus I4 plus I5. The sum of the currents entering into the junction equal to what? Sum of the currents leaving the junction. That is Kirchhoff first law. That is law of current. Okay, law of current. Or see the algebraic sum of the total currents. I1 plus I2, see minus of I3 minus I4 minus I5 equal to 0. So algebraic sum of the currents 0. Or the sum of the currents entering into the junction equal to sum of the currents leaving the junction. Okay, now sum of the currents leaving the junction. And next law of voltage or loop law. Law of voltage or loop law. That is, see, in a closed circuit, the algebraic sum of potentials and EMFs will be 0. This second law is very important. The algebraic sum of potentials and EMFs will be 0 in a closed circuit. So that is law of voltage or loop law. This is junction law. First law is junction law. And this is what? Loop law. Okay. Okay. So the algebraic sum of the potentials, that means as well as EMFs also, equal to 0 in a closed circuit. See, this is a circuit. See, positive, negative. See the direction of the current. See, these are all in series, right? So R1, R2, R3. Here A, B, C, D. Current is what? I flowing through this. Here I entering. See here the circuit should be closed to find the total potentials or total EMFs. The circuit should be what? Closed. Then only we can apply the Kirchhoff second law. So you can take any closed loop, see either clockwise or anti-clockwise. You will get the same. Suppose if you take in this A, B, C, D, A, closed loop. So here we have to follow some sign convention. The sign convention is very important here. Sign convention. Okay. Sign convention. What is sign convention? See, the sign convention is if the current is flowing in our path, then that is said to be negative. In opposite to our path is positive. And EMF's general direction is what? Negative to positive. That is positive. And if it is positive to negative, that is negative. Why? Because see, in our path means generally current direction is what, positive to negative. That means higher to lower. So current higher to lower means what? High potential to low potential. That is potential drop. Potential drop. That is negative. But negative to positive, lower to higher. So potential gain. So it will be positive. And EMF direction is what? Negative to positive. That is plus E. And positive to negative. That is minus E. So this is very important. Okay, na? This is very important. Now apply in this A, B, C, D, A. See, in this direction, see from A to B, current is what I, resistance R1. So potential is what I into R1. Potential drop is I into R1. See, positive to negative. That means potential drop, right? Decrease in higher to lower means so minus. Or see, simply for general case, what see, it is in our path. It is in our path. So same path means what it is negative. So minus I into R1. Next from B to C. So from B to C, here also see same in our path only. That means positive to negative only. So minus I into R2. And C to D. See here also same our path. So minus I into R3. That is positive to negative. And see D to A. Current is negative to positive. That means plus. So E minus I common. R1 plus R2 plus R3 equal to 0. So E equal to I into R1 plus R2 plus R3. So therefore I equal what? E by R1 plus R2 plus R3. Okay now. This is the current. Or suppose see if you take a reverse direction. Is anyone there? Give me your replies. See, if it is in reverse direction, that means, see, if you take here clockwise, A, D, C, B, A. See, from clockwise A to D. See, A to D, our path is C, positive to negative. That means minus E. And D to C, current is what? We are going from lower to higher. See, negative to positive means plus. Or simply in opposite direction. So, plus IR3. C to B. Same, opposite, right? Lower to higher. So plus IR2. Here. Plus, same na? Plus IR1 equal to 0. So minus E plus I into R1 plus R2 plus R3 equal to 0. So E equal to what? I into R1 plus R2 plus R3 again. So I equal to what? We have E by R1 plus R2 plus R3. See the case? In any direction you can take, but the final answer is what? Same. Final will be what? Same here. Okay, na? It is same. So next, Wheatstone Bridge. See, Wheatstone Bridge. So Wheatstone Bridge principle. See, based on this Wheatstone Bridge principle, we have, see here, 4 resistances. See, four resistance. Four resistances. You can